Okay, so welcome to AMF tutorials with Littlemusicbear. I'll be thinking of making another one or two more AMF tutorials before O levels on some of the other common topics that most people would have problems with, but since time is running short, please leave your comments below by mid-September so that I can make a better choice on which topics to go through. So just type in the topics that you want in the comment section below and I'll check. Okay, so today we are doing kinematics. Now I'm sure a lot of people have already known kinematics from both E-math and physics, acceleration, the distance, displacement, speed, and velocity. Okay, so today we are looking at differentiation and integration. So kinematics is one of the applications. Now, we want to find the value of t when the particle is at instantaneous rest. So, whenever you have instantaneous rest, always remember v equals to 0 because the particle is not moving. When it's at rest, the velocity is 0, the speed is 0, the particle is at stationary position. So now we have the acceleration, which is this, and we want to find v equals to 0. So the only way to do that is to find an equation for v. So, in case you have forgotten, in order to find velocity when acceleration is given, you have to integrate. So let's now copy the part first. A equals to negative 16e to the power 0.5t. And so v will be its integral. Negative 16e. Okay, now what do you do next? Just to remember how to integrate exponential functions. Okay, dt. Yep. Okay, remember your e is the logarithmic function, exponential. Yep. This e on your calculator is not the thing that you are going to differentiate or integrate as an algebra. So it's dt, not de. Then you get 32 e plus c. Always remember the plus c because there's this extra constant that doesn't have your algebraic variable inside. So wherever you integrate, remember the plus c. If not, marks may get the data and final answer may not be correct, and it'll affect your part B and so on. Now, let's look at the next piece of information. And anyway, if you cannot integrate this, please go and revise the integration of exponential functions because that's the basic thing, and without the basic thing you can't do this. Okay, next. With a speed of 28 meters per second, speed is velocity, v. So, let's see. Passes a fixed point O, which means that when it passes the fixed point O, let's say this is O, and when the particle passes O, at this point t equals to 0 because it has just passed O and time has not passed, and the speed is 28 meters per second. So we can substitute in when time equals to 0, velocity equals to 28. And we have this equation here. So we can find the velocity, but we have to find the value for the c first. So it's just we sub in the values. 32e. Okay. So this thing is equals to 28. Now, this is a lot. This is when power is 0, it's 1. So 32e times 1, you get back 32 plus c equals to 28, because e to the power of 0 is 1. Take note. Now you've got the c equals to -4. Once you have this part done, you can now substitute the whole equation, because now you have the completing 32e here to the power of -0.5t minus 4. So use this to substitute. Okay, moving on. So we have when v equals to 0, because it's when the particle is at instantaneous rest. So v equals to 0, we sub in 32e power minus 4 equals to 0. Okay, so what can we do here? We can bring the 4 over and divide it by 32. So e equals power negative 0.5 t equals to, it's positive because bring it over to the other side, so sine 4 over 32. So you can get rid of the 32 and the 4 here. Now then, which is equivalent to simplest form 1 over 8. Now, how do you get your t? Use ln. So 0.5t will be equals to 0.18. Now you get the e gone, so you have to figure out this thing. But it'd be more convenient if you express it in terms of t, of which you can just take t equals to ln of 8 divided by -0.5. So first on the calculator, ln 1 over 8 divided by -0.5, you get this, and this is the answer. So equals to 4.15888 equals to 4.16. 3SF. And done. 6 marks down. Okay, so thank you for watching another episode of AMF Tutorials with Littlemusicbear. I hope you enjoyed the video. Bye!